Imagine coming home, weary but refreshed, from an invigorating camping trip. The great outdoors has worked its magic, but now, reality sets in. You're faced with a mountain of dirty laundry. Clothes are caked in mud, smelling of campfire smoke, and generally looking worse for wear. You gather everything, muddy pants, grass-stained shirts, even that delicate fleece, and toss it all into the washing machine. With a sigh of relief, you press a button, select a seemingly appropriate cycle, and walk away hoping for the best. An hour later you return, and to your surprise, every item is not only clean but also remarkably well cared for. The mud is gone, the colors are vibrant, and even the delicate fleece feels soft and fluffy. It's perfectly clean. But how did the machine know exactly what to do? How did it manage to clean everything so effectively without damaging anything? It didn't just follow a rigid, pre-programmed set of instructions. It wasn't simply executing a fixed sequence of commands. Instead, it adapted to the specific load, making smart, nuanced choices about water temperature, wash time, and spin speed, all tailored to the unique needs of your laundry. This seemingly magical feat isn't magic at all. It's soft computing at work, quietly and efficiently behind the scenes. Unlike traditional computing, which demands precise inputs, exact rules, and absolute numbers, leaving little room for interpretation, soft computing thrives on the inherent uncertainty and ambiguity of the real world, embracing the nuances that traditional systems struggle with. Instead of relying on hundreds of strict, inflexible if-then rules, it uses flexible, human-like reasoning, employing terms like a little dirty, moderately soiled, or very dirty to guide its actions. This allows machines to effectively handle the messiness and unpredictability of real-world situations, mirroring the way humans intuitively solve problems. Traditional computing excels at precise mathematical calculations, but it falters when faced with fuzzy, subjective problems like determining what clean enough truly means. Soft computing, on the other hand, embraces the gray areas, the uncertainties, and the subjective judgments that are so common in our daily lives. It focuses on teaching machines to be adaptable, resilient, and capable of making sound decisions, even when faced with imperfect or incomplete information. That's how your washing machine transcends its role as a mere appliance and becomes an intelligent assistant, capable of understanding and responding to your needs. It represents a new paradigm in problem solving, one that's fundamentally changing the way technology interacts with and works for us, making our lives easier and more efficient. Soft computing is the underlying secret behind the rise of smarter, more intuitive, and ultimately more helpful machines that are seamlessly integrated into our lives. And it all starts with the ability to gracefully handle the inherent messiness and complexity of everyday life, transforming mundane tasks into effortless experiences. So what is soft computing? It's a set of techniques inspired by nature and the human mind. Unlike hard computing's rigid logic, soft computing handles uncertainty and partial truths. Lotfi Zeta, the pioneer, realized machines need to reason with fuzzy information to be truly smart. Think of it as the difference between a strict thermostat and your own sense of comfort. Soft computing weighs many vague factors to make better decisions. It's not about replacing hard computing but working alongside it to solve messy, complex problems. That's how we get technology that's more intuitive, adaptable, and human-like. Soft computing boasts a powerful toolkit, and at its heart are three remarkable stars, each contributing its unique brilliance to solve complex problems. First, fuzzy logic, then neural networks, and finally, genetic algorithms. These are the core components. Fuzzy logic powers your smart washer, intelligently handling shades of dirty instead of just clean or not. It understands the nuances. Neural networks mimic the brain, learning to recognize patterns, a fundamental aspect of intelligence. They can perform complex tasks like spotting cats in photos or efficiently sorting emails. Genetic algorithms borrow from evolution, rigorously testing and evolving solutions through generations until they find the best one, the most optimal outcome. Each tool brings unique strengths. Fuzzy logic excels at handling ambiguity, neural networks shine in learning from data, and genetic algorithms are masters of optimization. Often they're combined, for example, a neural network analyzing data to extract meaningful insights, then fuzzy logic making the final call based on that analysis. This blend creates systems that are truly intelligent, adaptable, and capable of handling real-world complexity. That's the magic behind many smart technologies we rely on every day. You use soft computing every day, often without realizing it. Your washing machine uses fuzzy logic to adjust cycles for every load. Email spam filters rely on neural networks to spot junk, learning, and adapting as new spam appears. Weather forecasts use neural networks and genetic algorithms to sift through mountains of data and predict what's next. Even video games use fuzzy logic to make characters act more realistically. From your kitchen to your inbox to your favorite game, soft computing is everywhere. It makes technology smarter, more efficient, and more helpful. It's the invisible engine behind your daily tech. Soft computing is quietly transforming the world around us, revolutionizing how machines solve problems. It's shifting away from rigid programming and instead, it lets computers handle the messy, unpredictable real world, the kind of world we live in every day. It excels at finding patterns in data, even when that data is incomplete or uncertain. Soft computing is also adept at optimizing complex systems and understanding human language with all its nuances and ambiguities. Neural networks, a key component, help businesses and scientists uncover hidden insights from vast amounts of information, while genetic algorithms optimize everything from delivery routes, making them faster and more efficient, to power grids, ensuring a stable and reliable energy supply. Voice assistants use soft computing techniques to understand you, even with background noise or different accents. By embracing uncertainty and approximation, soft computing bridges the gap between people and technology, making interactions more natural and intuitive. It's why your phone recognizes your face even in varying lighting conditions, and your car adapts to slippery roads, keeping you safe. Inspired by nature's problem-solving abilities, soft computing is building a smarter, more efficient future for all of us. And that's a revolution worth noticing, a revolution that's quietly changing everything.